Welcome back to Batch Math, where today we are going to continue our discussion on solving special right triangles. If you haven't already, please feel free to check out my video over 45, 45, 90-degree special right triangles. This video is a follow-up to that one over the other special case, 30, 60, 90 triangles. Now, generally, these are considered just a bit harder, and that is because we don't have those legs being the same length here. We've got three different angles, so we're going to have three different lengths of sides that correlate with those three different angles. Now, you'll notice that I have, say hi to DJ here. Hi, DJ. Anywho, just like in the last video, I have brought up two different examples for your notes here. You'll see that the first example has a variable x, and then we have the same ratio between side lengths represented in the second example. It is just showed with variable a there instead. Those variables are interchangeable. Now here's what's not interchangeable. In the problem given to us, they have already defined x. If you'll notice, because it is across from our largest angle, in this case our 90-degree angle, it is our hypotenuse. But in both of the given notes over here, the hypotenuse is defined as 2 times the variable. 2 times the variable. So if we set x equal to 2x there, that's inaccurate. We cannot do that. So in this case, we are going to want to use the second reference. So I like the color code, and because we don't have those equal in length legs here, we have leg Y. If you'll notice, it is across from our unlabeled angle in our figure, but we have 90, 60 by default. That has to be a 30-degree angle. All right, 30-degree angle. And as a result, that means we find our 30-degree angle. Y is equal to A. And last but not least, we have this 5 square roots of 3. It is across from the 60. If we look in our reference figure, across from the 60 is A square roots of 3. And if we look at the color coding, we can set all of those things equal to each other. And we'll notice 2a equal to x, that's not helpful, 2 variables. A equal to y, that's not helpful, 2 variables. But 5 square roots of 3, is that equal to a square roots of 3 is helpful. We have one variable there. We have an equation. We must use our equation solving skills, which say what we do to one side of the equation, we must do the exact same thing to the other side of the equation. That retains the original value. Now, in this case, we'll look at the relationship between a and square roots of 3. That is multiplication. We will be dividing opposite operation equally on both sides of the equal sign to isolate the a variable there. And lucky for us, that's a lot more manageable. A is equal to 5. That makes the rest a lot easier. I'm going to go ahead and jump to y. We know that y is equal to a. We know a is equal to 5. By the substitution property here, we substitute 5 in for a, and we know y equals 5. And we're almost done. The other unknown is to solve for the x. In this case, x is equal to 2a. We know that a is equal to 5 right here. Bring that fact on down. A is equal to 5. We substitute that a in there, and we get x equal to 2 times 5. 2 times 5 is 10. And so x is equal to 10. In this case, we want to look at what x and y are. And there are side lengths on a triangle. So lengths have units associated with them. And on this sheet, units were not given. However, as I said in my previous video, there are some exams that if you're giving a length or a distance and you don't put that this is units, they would count off. All right. And because x and y are side lengths, we label those as units. And there you have it. Special right triangles, 30, 60, 90 triangles, where we find unknown side lengths. Thank you so much for your time.